In this module, we continue the conversation on stub area types. We're going to pick up right where we left off, and now we're going to be looking at the totally stubby area. And you can see we've got that one in bold here. Now, quick note on the totally stubby area. This was a Cisco proprietary convention, right? So Cisco took a look at the RFC and said, hey, it's great that we've got this stub area here, but you know what would make it even better is that if we've only got a single point of ingress and egress into that area, why would we put all of that inter area, those OIA type 3 routes, or I should say LSAs, into the stub area when a simple default route is all that's going to be needed? And so that's where the totally stub, and when you look at the names here, you can clearly see that the standard is stub and not-so-stubby, and if the word totally is in there, just think that it's totally Cisco, right? So those are both Cisco proprietary, the totally stub and the totally not-so-stubby area. So our focus again here in this module is on the totally stub, where again, no type 5 LSAs are going to be allowed in any of the stub area types. They all share this. No virtual links can use the stubs as transit. So what's different about the totally stub when compared with the stub? And again, with the totally stub, the only LSA types we're going to see type 1, type 2, and we're going to see the default, which is going to show as an OIA, right? So there will be no type 3s, with the exception of the default, no 4s, no 5s, no 7s. So type 1, type 2, and the default. And again, that network layer reachability information is filtered by the ABR for the 3, 4, 5s, and 7s. Now, the ABR is again going to be responsible here, and it's going to happen. You'll notice that when we did it with the stub, the injection of that default happened auto-magically for us, right? It just showed up there in the routing table on router 7. And the same is true with the totally stub. Now, the E bit, right? Again, it's the stub flag. So the E bit is still going to be cleared. It's going to be set to 0. Now, this is one of the sort of semantic type things with setting up a totally stub. Now, you're very familiar with the area, and we'll say area 127 stub command, right? So each of the interfaces on the routers that are in area 127, when it was just a stub, needed to have area 127 stub. And that went for the ABR as well. And so let me get the drawing tool up here. You can see for the ABR, it was the same thing where we just needed to have area 127 stub. But now we're talking about a totally stubby area. And totally, right, you can think of totally as meaning no summaries. So there are no type 3 LSAs that are going to end up in a totally stubby area, right? So no summaries referring to those type 3 LSAs. Now this command, this area 127 stub no summary, is only required on the ABR. In other words, I could say area 127 stub no summary on all of the routers in area 127 that are in that stub, the totally stubby area, but it's not gonna, it doesn't do anything special on internal, or we'll call them leaf routers, right? So routers that are simply, hey, we just have an interface in area 127 and that's it. So the proper way to do this, right, the correct way to do this is on the ABR, you say area 127 stub no summary, because again, remember, it's the ABR and only the ABR that is responsible for filtering that network layer reachability information, right? The leaf or internal routers to area 127, they're not responsible for that. Because again, they're not ABRs. They are internal leaf routers in this totally stubby area. So to do this correctly, we put area 127 stub no summary only on the ABR, and on all of the leaf or internal routers in the totally stubby area, the non-ABRs, we're going to simply say area 127 stub. That's all that's needed. Now, the same rule applies. You cannot have an ASBR inside a totally stubby area, right? Just like the stub area, we couldn't do it with an internal leaf router, right? We can't redistribute information. We can't do it here with a internal leaf router. So it can't be an ASBR. We can't put an ASBR in there. So let's do this. Let's clear that. And let's go back through the deck here. And this is going to take us to some of the configuration commands. But let's get on the command line now. And let's sort out what needs to be done. And again, we're picking up right where we left off. You can see we're still staring at this error here. So we'll remove that redistribution statement. And I've updated the, I was going to say Visio. I've updated the diagram here. So we're talking about a totally stubby area. So again, no type 3s, no type 4s, no type 5s, no type 7s. So in area 127, we're only going to get the type 1s, the type 2s, and the default. So let's go ahead and take a look here. So let's get rid of that command. Let's say do show run section OSPF. And let's say no redistribute connected subnets. And I believe that it's going to leave behind. Okay, it did not. Good. So now we've gotten rid of the error that we were seeing, that log message here, right? Because we were trying to redistribute and make router 7 an ASBR. Well, we can't because it's an internal leaf router in area 127. Now, what do we need to do to make this totally stub? So do show IP route OSPF. Remember what we're seeing here is we're seeing the default, right? So here's our default, which comes in as a type 3. However, we're seeing all of this other inter-area information that we don't need to see for reachability. In fact, remember that external information when if I said do ping 2.2.2.2, right? So this was that external information that's over in the EIGRP domain. Now, I don't have reachability to it because, again, I'm probably missing routing information in the EIGRP domain, and it doesn't know how to get back to this, and so we could sort that out later. But, again, this external information, I don't see this here because it's a stub. But now let's go ahead and make it a totally stubby area. So we get on to router 12, and do show run section router OSPF. And you can see the area 127 stub. The only change that needs to be made is I simply say stub. If I do a question mark, you can see we've got some different options there. Is simply area 127 stub, no summary. So again, the external bit is still clear. The E bit or the stub flag, right, is not, or I should say the stub flag is set, but the E bit is not set. It's cleared, right? It's at a value of 0. So if we were to come back over here to Wireshark and I were to kick off a packet capture, what would we expect to see in the hello messages that are going to go between router 12 and router 7? So there's some hellos for 7 here, so we'll take a look. The adjacency is still up, and take a look. External routing capable? No, not capable. Here's 12 sending hello packets, right? And what do we see? External routing capable? Not capable. Because again, for area 127, it's been set, and there's the area ID. It's been set so that it is not capable. We've made it a totally stubby area. And so what does that mean now for router 7, that internal leaf router in area 127? So if I was to say do show IP route OSPF, that is it. And that is the ultimate optimization of a stub area, right? To make it a totally stubby area. Because again, it doesn't need any other information in this scenario because there's a single ingress and a single egress point. So if I was to try to ping, what is it, router 11s, do ping 11, 11, 11, 11, right? So that's the loopback address on router 11, which is 3 hops, well, 1, 2, yeah, it's 3 hops away. So we have no problem because, again, there's only one way for me to get to that information, and it's out that fast Ethernet 00 interface via router 12. So that makes sense, right? And so this is really what the totally stub is doing. And from a link state database perspective, do show IP OSPF database. What do we see? Do I see type 1s? Absolutely, right? We're always going to see type 1s. So here are the type 1 LSAs for router 7 and router 12. We see the type 2 LSA, the network LSA, with the IP address of the DR, the designated router for this segment. And again, remember, I'm going to keep caveating this. Broadcast, I'll just put broadcast, and non-broadcast multi-access. That's where we're going to see this network link state LSA, right? And then the type 3 summary network link state. The only thing we see is the default. And again, there it is right there. Who's advertising that? Who's injecting this default? It's happening auto-magically here on the ABR, on router 12. In fact, there's another way for us to see this information. If I was to say, do show IP OSPF database summary, and I believe, oops, we're going to go quad zeros there. I think that's the syntax. There it is. So here is the LSA that comes in. Now, something else that's important, and we're going to talk about setting the metric or the cost on the default route. So when the ABR injects that default, it comes in with a metric of 1, right? And so this is an exception. Well, I shouldn't say it's an exception because the default seed metric for external information is 20. The default seed metric for a default route via the ABR is going to be 1. But we can manipulate that, and we'll take a look at the area default cost command here shortly. But let's take a look. Routing bit is set, right? It means that this is a valid LSA. We've got the link state age, and here it is, link state ID, quad 0, summary network number. And again, it's the quad zeros. There's the advertising router. And then we've got the network mask, right? It's just a 0. Okay? And so here is the actual LSA, the actual type 3 LSA that we're receiving from the ABR. So let me go ahead and clear this. All right, and so that is the major difference. Again, Cisco looking at this, looking at the stub area and saying, how can we further optimize a stub area when in fact there's only a single way in or out of that area, and it is to make it totally stubby. And again, the same rule applies that if I was to say redistribute connected subnets, we're going to see that warning log message, right? Severity level 4 from the OSPF facility in the mnemonic ASBR without valid area. So I'm trying to create an ASBR here, but this is a totally stub area. Just like the stub area, we cannot set this up. In fact, let's say do show IP OSPF, and this is, you can see right here on router 7, right, it says is an autonomous system boundary router. And you can see here, and this is interesting, where the show IP OSPF command thinks that it's an ASBR, even though we were just told that it can't be an ASBR. And the reason is because when we say do show run section router OSPF, what we see is that redistribute connected subnets. So let's go ahead and say no redistribute connected subnets, and then say do show IP OSPF. Now what kind of a router does it say it is? Do you see any statement in there about it's an ABR, it's an ASBR? No, nothing, right? That's gone. On 12, we're going to see that it's an ABR. Do show IP OSPF. And there it is. It's an area border router. So interesting that you get the log message, the syslog message telling you that router 7 cannot be an ASBR, but when you say do show IP OSPF, it says it's an ASBR. even though it's not. It can't be. All right. Well, this is going to wrap up the totally stubby area. And now we're going to move in. We're going to address one major thing that we've seen so far is, you'll notice I keep saying you can't be an ASBR. You can't be an ASBR and be in a stub area. And now we're going to talk about RFC 3101, the not-so-stubby area that's going to address that issue. And the issue specifically being, how am I able to redistribute external information into a stub area? What if that's a use case that comes up? All right, thanks so much for watching, and I hope to see you in the next module.